Hello and welcome everyone. Thank you so much for joining us today. I'm Myron Van Ert, Chief Commercial Officer at ZwitterCo, and today we'll discuss the ever-growing water challenges across the Middle East and Africa region. And specifically, we'll discuss how advanced membrane technology can help unlock new water resources and enable industrial resilience. So let me quickly introduce our speakers. I'm joined today by ZwitterCo CEO and co-founder Alex Rappoport. Alex is a visionary behind ZwitterCo and thought leader in the water tech innovation space. Also, Ali Ben Hamida is our executive for the Middle East and Africa region. Ali's a water veteran that leads all activity in the region and brings a wealth of experience to this conversation. And finally, myself, as I mentioned, I'm the CCO at ZwitterCo and lead our commercial efforts across the globe. And I also happen to previously spend 5 years as the Middle East and Africa region CEO for the former GE Water business. So you'll hear from each of us throughout the presentation. So to get us going, I'm going to hand things over to Ali.
Thank you, Myron. The Middle East and Africa are among the regions most severely affected by water scarcity. In the following few slides, we will take a look at the key factors contributing to the intensification of this issue, as well as highlight some of the initiatives and strategies being implemented by governments in the region to mitigate and address water stress. The Middle East and Africa is the most water-stressed region in the world. According to projections by the World Resources Institute, by 2050, 100% of the population in the region will be living under conditions of extreme water stress, requiring significant adaptation measures. Also, the region is experiencing rapid population growth, which places further strain on already scarce water resources. In the Middle East and North Africa alone, the population is projected to exceed 500 million by 2050. Also, rapid urbanization, particularly in major cities such as Cairo, Riyadh, and Dubai, further increasing the demand for water and increasing the strain on existing water sources. Furthermore, climate change is greatly intensifying water insecurity throughout the region. Higher temperature, reduced rainfall, and more frequent droughts are all worsening the severity of the water stress. Many countries across the Middle East and Africa rely heavily on seawater desalination, groundwater aquifers, and transboundary water resources. However, there is a growing need to transition toward more sustainable solutions, including water reuse, an area increasingly enabled by advanced technologies such as those advanced by ZwitterCo. Governments across the region are rapidly responding, seeing water security as a strategic imperative. Saudi Arabia has emerged as a global leader in this space, placing strong emphasis on innovative and sustainable water management solutions to address its long form of term water security challenges. In 2023, Saudi Arabia established the Global Water Organization headquartered in Riyadh, the capital of Saudi Arabia, further reinforcing its commitment to advancing international collaboration and innovation in sustainable water management. Saudi Arabia is also set to host the 2026 World Congress of Desalination and Water Reuse Solutions, underscoring its leadership in the global water sector. As part of the broader reform agenda, the Kingdom launched Vision 2030 under the leadership of King Salman bin Abdulaziz Al Saud, with Crown Prince Mohammed bin Salman serving as the primary architect and driving force behind the initiative. This initiative is a national strategy aimed at modernizing water management. This initiative seeks to address the adaptation of non-renewable groundwater and meet the high water demand of its urban, industrial, and agricultural sector by promoting conservation and deploying advanced innovative technologies to reclaim fresh water from unconventional sources. Similarly, the United Arab Emirates regards water security as a fundamental pillar to its national security. To address this critical issue, the UAE has implemented its Water Security Strategy 2036, outlining a comprehensive plan to ensure sustainable and resilient water resources for the nation's future. This strategy aims to reduce overall water demand by 21%, enhance the water productivity index, which measures the economic value generated by unit of water consumed, lower the water scarcity index by 3 degrees, increase the reuse of treated wastewater to 95%, and expand the national water shortage capacity to cover up to 2 days of demand. Given the limitation of natural water resources in the region, desalination facilities will continue to play a crucial role in meeting growing demand, especially desalination from the sea. However, achieving the region's long-term water security goals will require a broader and more integrated approach beyond desalination alone. All of the world's 10 largest seawater desalination plants are located in the Middle East, highlighting the region's reliance on this technology to address its water scarcity challenge. However, desalination plants alone are not enough to meet the region's growing water demand. Consequently, there is an increasing emphasis on identifying and utilizing non-conventional water sources to supplement supply. As an example, treated water effluent, known commonly as TSC, and treated wastewaters, TWW, are two non-conventional sources already being utilized in the region. While not for direct human consumption, TSC and TWW are primarily used for agricultural irrigation, industrial processes, central cooling stations, and groundwater recharge. National strategies across the Middle East and Africa, such as Saudi Arabia Vision 2030 and the UAE Water Security Strategy 2036, actively promote water conservation, the treatment and reuse of wastewater, and environmental protection initiatives. To address these objectives, the deployment of advanced treatment technologies became essential and a must. The region is actively seeking new technologies that offer greater efficiency than current systems in the following areas: seawater desalination, groundwater treatment, water reuse, advanced wastewater treatment, TSC, and TWW. Water scarcity is a pressing concern in the Middle East and Africa, where the availability of fresh water resources is very limited. Given that industries such as meat, poultry, and dairy demand significant quantities of water for various purposes such as drinking, washing, and cooling, the scarcity of water resources poses significant challenges. What is the solution here? We believe reuse is the solution. As discussed, treated sewage effluent and industrial wastewater are increasingly reused for irrigation, industrial, and now even some portable applications. Recently, there has been a big emphasis on sludge-to-energy technologies and the resource recovery, which we expect to see continue throughout the decade. Now, I will hand it over to Myron to talk about the number one challenge for wastewater treatment for reuse application, which is organic fouling. Take it away, Myron.
Thanks, Ali. As mentioned, one of the key challenges in enabling water reuse is the issue of organic fouling. Although membranes are key to unlocking reuse, organic levels in wastewater can be high and have always presented serious fouling issues to conventional membranes. Organic fouling is a problem because it is very sticky to membranes and accumulates, thus causing issues. When this fouling occurs, performance declines, it takes more energy, pressure to deliver the treated water desired. Cleaning is then needed to remove the foulants, but some of these foulants may not be removed via cleaning. This is known as irreversible fouling and permanently impacts membrane performance while contributing to shortened membrane lifetime. As a result, fouling leads to excessive downtime for frequent cleaning or maintenance, makes it difficult to deliver design permeate flow, increases your OPEX by requiring more frequent cleaning, as well as shortening membrane life. In order to tackle reuse, membrane fouling has been long researched as a major challenge, and the industry has spent decades trying to address the issue. Today, there are low fouling and fouling resistant RO membrane elements available, but many of these feature a standard RO membrane that's simply treated or coated with a chemical to give it some of those properties. But these attributes can deteriorate and degrade. There are also new feed spacers that are either thicker or have unique geometries to improve membrane hydraulics and minimize fouling. But even so, these are also still susceptible to organic fouling and will require frequent cleaning. And so this is where ZwitterCo is different with our breakthrough innovation of zwitterionic material chemistry. So now to talk just a little bit more about our unique membranes, I will turn the mic over to ZwitterCo's co-founder and CEO, Alex Rappoport.
Thank you, Myron. So at ZwitterCo, we solve membrane fouling starting from the fundamental materials that we use to build our membranes. We work with a novel chemistry, the zwitterionic copolymers, for which the company's name originally comes from. And this gives the membranes unprecedented fouling resistance. We'll talk about how in just a moment. We use this novel chemistry as a platform to build membranes across the separation spectrum, and then we build these membranes into standard dimension filtration products and engineered membrane solutions that are designed to handle challenging water, wastewater, and process applications. So we're going to get into just a little bit of a chemistry lesson here to talk about the innovation at the fundamental material basis for how the membranes are built. First, zwitterionic copolymers are extraordinarily hydrophilic or water-loving materials. This means that they preferentially bind to water molecules. They can attract and hold on to water, hydrating kind of like the way that a sponge would soak up water if you held it under a faucet. Now, when we build membranes out of these water-loving zwitterionic materials, because of that hydrophilic nature, water can pass freely through the zwitterionic layer. But larger molecules, contaminants that you might be trying to filter out, like fats, oils, greases, and proteins that are too large to fit within the pores of the membrane, aren't able to pass through. Now, this is where membrane fouling normally occurs, because as you pressurize contaminant molecules against a surface, they typically like to stick or they infiltrate the pore network, and that's what clogs up your membrane. But the zwitterionic material and that hydrophilic behavior changes this phenomenon. Because the membrane holds onto water molecules and stays fully hydrated, the water forms almost a barrier or a shield that prevents organic compounds from sticking down or bedding to the surface, leading to the permanent adhesion that causes fouling. If you look at the images over to the right, you can sort of see an animation of how the water-loving channels that are holding onto water are serving as a boundary that prevents the organic compounds from sticking or bedding down. Coming back to the sponge analogy, it would be like you're trying to take adhesive tape and try to stick that to a wet sponge. The water molecules would prevent the adhesive from actually gaining any purchase or leading to that sticking phenomenon that leads to fouling. Because the membranes are able to resist this sticking, it makes cleaning and recovering the filtration performance really easy with either generic chemical cleaning agents and often very simple, very fast, and very cost-effective maintenance programs, which allows these membranes to operate even in very challenging environments. Let's take a look at what that looks like in reality. So we've put membranes in front of all sorts of very challenging high-strength wastewaters and complex separation applications that are either often very costly to use traditional membranes or are simply not feasible because of how quickly you would see membrane fouling occur. The video you're seeing here on the left is an example of our membrane cleaning after it's filtered wastewater from a poultry slaughterhouse. You can see all of the meat sort of derivatives, the fat, the protein, the oil that accumulated on the membrane surface, easily skimming off and returning that membrane back to its starting permeability. We see this same easy cleaning and maintenance possible whether you're treating fluid from food processing applications like meat, dairy, grains, and other sort of starch-based compounds. We also see it in light and heavy industrial applications like leachates, oil and gas, refineries, chemical processes, and other examples where you see high organic strength in these complex wastewaters. We've built our membranes now into a couple different separation classes that serve different functions, but that all maintain this extraordinary fouling resistance. We have a tight ultrafiltration product, which is ideal for concentrating food-grade proteins, like what you would see in a dairy application or in biopharmaceuticals. This can also be used to purify small molecules, like what you would see in sweeteners or other food-grade small molecule purification. We have a superfiltration membrane, which is even tighter than our UF. SF is roughly 1,000 Dalton molecular weight cutoff, meaning it removes everything larger than a nanometer. Superfiltration is really effective at removing not just emulsified, but also dissolved organic compounds, producing the ideal feed water for a downstream polishing or desalination product. So superfiltration is a very strong pre-treatment tool to get all of the difficult to remove organics out of water. And then we have a brackish water reverse osmosis membrane that is a one-for-one substitution for traditional brackish applications that might be struggling with more downtime, more cleaning, or more frequent replacement due to organic fouling. So this gives us a way to immediately attack purification, water treatment, wastewater reuse processes where membranes are installed, but they might be struggling due to their propensity for fouling. So as we've talked about the chemistry, how the membranes work, and their ability to handle these complex streams, and now looking at a few of the different membrane separation classes we have commercially available, let's get into some of the commercial applications of these products that we have running or that are about to start up in the region. Ali, Myron, back to you.
Fantastic. Thanks, Alex, for going through that. So now, though we've only been on the ground in the region for less than a year, we have some really compelling commercial projects that we'd like to go through that represent good examples of the technology. So, Ali, floor is yours.
Thank you, Myron. Another example of ZwitterCo impact in the region is at the Sartex textile plant in Ksar Hilal, Tunisia. The wastewater from the textile manufacturer is high fouling in nature, but local water authorities are putting significant pressure on Sartex to stop discharging the brine to its sewer network. So a solution needed to be found. Sartex has chosen to refurbish an existing RO system on site with ZwitterCo high rejection brackish water RO elements in order to reduce its brine volume and enable compliant disposal. As part of this study for the zero leakage discharge, known as ZLD project, Sartex requested ZwitterCo to propose an appropriate solution to this issue of reducing brine volume discharge. They were looking to reduce their brine from 300 cubic meter per day to 100 cubic meter per day in order to reduce both CapEx and OpEx. We have determined that by simply recovering and refurbishing the existing RO system, the desired objective can be easily achieved by replacing the existing membranes in stage 1 with ZwitterCo RO high rejection membranes. Sartex has placed a purchase order for 25 RO ZwitterCo membranes, and the commissioning is scheduled for the next month in July 2025. Now I will turn the microphone over to Alex to talk about our collaboration with Water Services Corporation, WSC, in Malta.
Thank you, Ali.
Alex.
We're really excited to be working with WSC. That is the water authority that oversees all of the front end drinking water production through their groundwater and desalination plants, through to distribution and conveyance throughout the Maltese Islands, wastewater services, both collection and treatment, and then finally reuse of a fraction of their wastewater for reclamation for industrial and agricultural projects throughout the country. WSC is a very pioneering group. They've been a leader in desalination for the last 40 years. Their work in the New Water program, their reclamation, that's been online now for 7 or 8 years, is one of the most advanced examples of how we can take collected sewage wastewater and use it as an offset to freshwater consumption, which is really important for the country of Malta because they are one of the most water scarce nations in the world. They have challenges with both shrinking groundwater supplies and seawater intrusion that's leading to increased salinity of their groundwater, and they're already making these incredibly proactive steps to offset the need for water from their aquifer and instead supply that both with increasing desalination reserves and increasing their levels of reuse throughout the island so they can maintain that kind of independence and resiliency as climate change continues to affect the islands. So today they have 3 of their reuse plants where they're using additional membrane-based treatments, ultrafiltration, brackish RO, and some final AOP and UV processes to get back to effectively potable grade water. They're producing over 7 million cubic meters per year of this reclaimed water today, and they're expecting to more than double that capacity, again, both to serve the increasing water demands of the country and to try to get off of their current reliance on groundwater. In order to do this, they need to be able to source innovative technologies that both increase the efficiency of their reclamation plants and that allow them to attack some of the more challenging industrial wastewaters that sometimes reach their centralized treatment facilities and that can create disturbances with how they're managing the country's wastewater. So what we're excited to partner with them on is their country to company model, where they are making these sort of top-down collective investments and technology sourcing projects where they can introduce novel solutions for their high-strength industrial wastewater producers. We have two different developments going on with WSC right now. First is installing our fouling-resistant brackish RO membranes within the reclamation facilities. This is going to help us both increase the productivity by reducing cleaning frequency, reducing the intensity of cleaning, because right now their RO systems do have some pretty severe organic fouling challenges that show up pretty regularly. This helps us build resiliency and build efficiency in their current reclamation plants and be there as those plants expand to help increase the production of this recycled water. And we're also looking at some of the high-strength industrial wastewaters coming from farm and agricultural wastes, from food processing like dairy and tomato production, from breweries, meat and poultry, leachate. There's sort of a collection of different industries that have been known to discharge high-strength wastewater and that can overwhelm the treatment capacity of their centralized plants. And the goal is to find point source solutions that can remove this risk of challenging effluents reaching the centralized treatment facilities so that they can ensure that there are no upsets or no challenges with how they meet their compliance requirements. And in those projects, we're looking at a combination of both superfiltration and the brackish RO membranes, providing these unique ability to tackle the high strength wastewaters directly at the source of production.
All right. Thanks, Ali and Alex, for reviewing those exciting projects we have going on in and around the region. All right. At this point, we're going to open this up to conversation to answer some of those questions that the audience has submitted during the webinar. So we'll get started on that, and all of us will kind of weigh in on them. All right. First one that I see is what is your strategy for supporting businesses in different countries in the Middle East and Africa? Ali, why don't you kick that off for us?
Okay, our strategy to do business in Middle East and Africa is that, of course, through our partnership, basically with both the end users and the EPCs and the system integrators. Our strategy go-to-market has been since we started looking at the region is basically going directly to the customers, like, the examples we gave, Water Services Corporation in Malta and Mudun and others, is basically to position our solution first to find what are the pain point of the customers and try to work with them to find solutions. And it's been very positive in terms of creating demand for our technology here and then showing the interest we have seen from the customers and partners. And it's been really a good work relationship since we started going into the market here.
Yeah, I'll piggyback off of that. Ali's absolutely right. Partnership is a key facet of how we're thinking about doing business in these countries. We are both growing a network of local consultants who are able to help us identify some of these key end user projects. So a lot of times, discovery and understanding customer needs is something that our team will do directly. And we're growing our boots on the ground presence throughout the Middle East and Africa to help support those direct end user engagements. In certain circumstances, if someone is already using a membrane product and that is seeing some level of distress from organic fouling, we can transact directly and we can deliver those membrane products and provide both the in-field support and remote support needed to help customers get the full value out of the technology and to be able to make sure those projects are wildly successful. When we think about more complex integrated projects where you're delivering new equipment, delivering infrastructure that enhances reuse, that's where we expect to be working with a local network of OEMs or integrators for whom we will be in a very close relationship during both the upfront process design phases where you're understanding how the mass balances and how the system configurations are going to serve the final projects, as well as throughout the detailed engineering and project delivery phases, really making sure that our local partners are leveraging the best expertise of the company for how to design these solutions. So we're very interested to both connect with end users if they are identifying ZwitterCo technology as something that they want to try, and then we could find the right distribution model, depending on whether it's a direct replacement of components or whether new equipment needs to be built, and we can work with partners that we have a growing relationship with to deliver that equipment.
Fantastic. All right, let's scanning through the list of questions. Let's see. Next one we'll grab is how is the Middle East Africa similar to or different from other regions in adopting new water technologies? I think I'll kick that one off. It's interesting. So we talked everything across all the stresses in the region, and Middle East Africa is probably one of the most stressed geographical regions in the world, by far. So there's a necessity and a demand there. And as you can see, we have a few projects in place that are going, and I think there's a lot of other promise that's there. If I contrast it against some of the other areas, if you look at Europe, there's a strong regulatory backdrop. There's a little bit more of a forward thinking around water reuse and things of that nature. So there's definitely a drive there. Um, by looking to APAC, there's kind of similar mix on scarcity issues, challenges, things of that nature. And then if I look at North America, it really comes around unique and novel solutions to big problems that customers are facing. So I think that when you look across the board, it's around where are the challenges to address very critical needs, be it in industry, be it in general around water accessibility and things of that nature. And it's finding those people that are looking at it and are willing to look at embracing new technology to help move this forward. So I think there's a lot of similarities. It's just a little bit different context around some of the backdrop of the industry, as well as the particular region. So, Ali, Alex, anything else you want to add on that question?
I'd say the urgency of these projects that we're encountering is a step above perhaps places we're seeing in other parts of the world because rolling water cutbacks, water shortages, day zero events are not a future, risk. They're things that are already happening. And so industries are already taking much more proactive steps to try to piece together novel, whether it's novel technologies or novel solutions that can allow them to start reusing water or better managing their waste effluents. We're seeing examples of membranes showing up in industries that wouldn't normally be applied because folks are trying to get to those higher quality treated effluents and trying to cobble together their own solutions. That creates an opportunity for a group like us to really partner with these pioneers who are already trying to make risk adjusted decisions for their facility and trying to get out in front of the curve for challenges with water security and resilience, because they're already trying to find and search for these novel solutions, and we can help provide them tools that are really engineered for these kinds of applications. I know, Myron, you spent a lot of time growing the business from the GE Water, Suez, and Veolia world in this region. Would you say that this is particularly now compared to where we were 5 or 10 years ago? Would you say that the trends of that urgency and that kind of idea that water reuse has become a license to operate in this region, would you say that's a development even from your prior life when you were running business in the region?
Yeah, absolutely. There's just a burning necessity. And so when in tackling that, everybody has tried to take approaches in which to address it. It's when you get these novel breakthroughs that you really start to get to an enablement. So absolutely, it has been a growing demand and sense of urgency, but I can honestly say that for across a lot of different regions in the world. It's just things are changing where there's this imbalance around the need and the demand around water versus what's available and what's there. So it presents a real challenge, but also a real opportunity to solve some of these issues and challenges.
I also think that water scarcity is starting to really show up in the economics. The dollars and cents of both accessing fresh water and cost of accessing either combined sewer or the potential penalties on discharge are actually yielding some pretty favorable economics to start installing reuse infrastructure because the value of the water is just higher in these regions where the reserves are dwindling. Ollie, were you going to jump in there as well?
Yep. What I wanted to also give a real example how the region is changing in terms of accepting and adopting new technologies. In the past, I've been here in the region for many years. Always it was locked for new technologies to be really installed and tried in projects. But we see that changing recently. And I'll take an example of that study we did and the project that I mentioned in the slide that we covered earlier was the Jeddah Industrial City and particularly the owner, Mudon. And the tender document that they launched recently is they said they mentioned really clearly that they're open to new technologies, which was not the case in the past. And I see that really a big change.
Absolutely. I mean, in the region, there's been all kinds of great advancement and investment across the industrial sectors and other areas. Yes, desal has expanded, but desal is much more expensive than looking at other water reuse solutions to enable water. And then look, as the progress and innovation happens across the Middle East region. I mean, there's a whole bunch of things around coming attractions on different things as it may be for data centers or other high-tech things which are incredibly water intensive and power intensive, which are only going to continue to stress. So as the region continues on its trajectory of innovation and development, you can bank on the fact that the water stresses will only be ever more on that side. So all right, let's move on. This one we hit on. Can these membranes be used both industrial water and domestic municipal wastewater? I think from our examples that we just went through, indeed we gave both. Both two were mixed, where they were both industrial and municipal, and the other one was purely industrial as well. So absolutely, that is a case in point that that can be used in those applications. Alex, I'll cue you up a couple here that are a little bit more on the tech side. So the
Yeah.
first one is superfiltration a microfilter or a UF?
Short answer is neither. It's closer to a UF. The right way to think about superfiltration is that it is a tight ultrafilter. It's really down at almost the nanofiltration level selectivity of organic compounds, but it does not desalinate. It does not have a meaningful rejection of mono or divalent ionic species. What's really exciting about that is that means it runs at low pressure. It acts more like a molecular sieve, not from a charge-based mechanism. So you can get the tightest level of organic removal, but you can still pass your mono and divalent ionic species. So you can run at what would be traditionally UF pressures. So you're going to get both the highest quality of permeate coming out of the SF compared to a UF, which still has pores that might pass some level of dissolved macromolecular compounds. SF is really good at taking out even the dissolved fraction, so that what you're basically passing downstream is like a clean brine stream. Sugar, salt, alcohol, water, those will pass, but anything larger is going to get retained. So think of it as like a tight ultrafilter.
Great. And then just scanning the list, I also see there's one on here about what's the max TSS that can be handled through an SF.
So there's a commonly adopted wisdom that spiral wound membranes need to be very carefully pre-treated for incoming suspended solids. And that's true, especially because of in any spiral module, you have pretty narrow flow channels or clearances for how water is going to enter the module. And so you want to make sure that you're not blinding off the scroll end of the membrane or that you're going to create flow path impingements with the solids coming in. That said, if you can remove the larger, what we call bulk solids, more fibrous or stringy material, typically down to something like a 25 or a 50 micron cut, we do see very strong performance of our SF membranes being able to handle solids as long as they're smaller solids, smaller, more spherical, more gelatinous solids. Those are typically okay to throw into an SF. The example here that we can draw from We've done a lot of work in fermentation mixed liquors, where you have biological material coming out of, say, fermentation. You can have pretty high levels of TSS, even up to, a couple percent TSS coming in, but biological material from those applications rarely leads to spacer fouling or flow path impingement. And so we can cycle up and concentrate up those solids without worrying about it impacting the membrane's ability to clean and recover, because you're not going to see that fouling effect coming on. So we say pre-treatment to take out bulk solids, and then from there, the superfiltration can do the vast majority of the job to get you back to reuse quality water or discharge safe water.
Fantastic. All right, I got a handful of kind of a grouping of questions. They're all kind of correlated. So I'm just going to put all three out and I'll let both of you comment. First is, what do I have to do to install a ZwitterCo brackish water RO? Second is, do I need to do system changes or operating changes in order to do that? And then also kind of related to that is, what's the easiest way to test your products? So I don't know, Alex, if you want to take a stab at that one?
So for installing an RO membrane, right, these are going to be standard dimension spiral products. They're going to fit inside of standard dimension pressure vessels, and you're really not going to be changing the way you think about how they operate, how they clean. We've intentionally engineered the product to be a one-for-one substitution with existing brackish RO installations. So from that standpoint, you're not going to be modifying the programming. You don't need special infrastructure changes on the system, and they're going to be operated within kind of the standard design parameters for how an RO would run. The difference is with our membranes installed, you're likely going to be able to tolerate having residual oil and grease, TOC, COD reaching the membrane. Your cleaning programs are probably going to be shorter. They're going to have less intensive chemical requirements. You're going to be able to use generic caustic and acid in order to maintain the systems. So the brackish RO is a really easy one to just drop in quickly, not a lot of changeover, and you can start seeing those operational benefits quite quickly. In terms of how you test it, we really recommend throwing in a housing or a train of membranes first, especially if systems have multiple trains. You can see one train running side by side with conventional membranes. You can really indicate the difference in how your cleaning and operating programs work. So we recommend for the brackish technology, just working with our commercial team and our applications engineering team on getting a first train running, and there's not a lot of changeover that's required there. Ali, do you want to jump in?
Sure. So the project that we covered earlier, the slides were, for instance, the Water Services Corporation in Malta, there was no any changes required. And as we speak, our team now are on site replacing one of the trains. And like Alex said, it's going to be a demonstration train versus the existing train to show the advantages of ZwitterCo membrane. So no requirements of any changes or modification of that. The other project that we covered was the SATEX project in Tunisia. It's also no modification would be carried out on the system, just replacing drop-in of the membranes in the existing pressure vessels. And the SATEX has not tested the membranes before, so we have not really tested our technology. So they believed in the advantages of our ZwitterCo. They saw that by putting our membranes in the first stage, where really most of the organics will be, and that going into that first stage will be basically handled by the ZwitterCo. So the technology for RO is really simply, there's no modification required for superfiltration. It's not interchangeable like it's the case with UF, but as we demonstrate, we cover the advantages of our superfiltration versus the normal or the conventional ultrafiltration.
Yeah, if you're an OEM who is interested in trying out the membranes and looking to deliver a new equipment solution, or if it's a end user here who's listening in and wants to look at a way to sort of completely reshape their wastewater treatment landscape and look at superfiltration as a pre-treatment, reach out to our commercial team. We'll provide contact information after this. But the goal there is to find the right path to do some subscale piloting to really understand the needs of the application. And we've got both pilot infrastructure that we can bring to bear, as well as a growing group of partners who we know have some systems that we've collaborated on the designs for that we can deploy in small scale demonstration projects. So happy to follow up with anyone who's interested there.
All right, excellent. I see there's one question that pops up a few times. I'll just take it real quick. What are the best ways to clean your membranes? You'll find that we are super user-friendly on that. It's basic chemicals. So acid and caustic. If you happen to be with our SF, it's chlorine tolerant. You can do that as well. But that is our cleaning regimen. And in fact, that would be our approved one that we would go through because some of the other formulated cleaners can you just want it needs to be approved, but it's basically strict commodity chemicals and the membranes reclaim very well, which gives you ease of access for the chemicals. And secondly, it gives you a great cost savings as well. All right. There's a bunch of other questions, but there's one I'm going to wrap up with is how do your membranes compare to other fouling resistant branded membrane products? So, Alex, if you want to take that one.
Sure. A lot of what we see in the industry today, when we're talking about the high-end products that are labeled as fouling resistant, they are still built from the same backbone chemistries that have been in service for 40 or 50 years. They may have additives that have come in post-processing. They may have some post-treatments that create some additional, fouling resistance in the coatings. But often these are both only incrementally different from what the conventional chemistry's behaviors, because you're still working with membrane materials that are inherently hydrophobic or that are natural, have a natural propensity to stick to the stuff that they're filtering out. And any of these post treatments typically have only temporary performance. As you go through subsequent cleaning cycles, you're going to wash off or wear off any of those protective layers, and you're going to basically be back to how a standard membrane would interact with those fluid environments. So we sort of see two challenges. One, they're unlikely to revolutionize the kind of organic processing that's possible. You might get a little bit of better performance, but you're not able to suddenly start throwing orders of magnitude higher strength fluids at the membrane. And two is it's likely very temporary. It doesn't deliver lasting performance over years of continual operation. What's different from our membranes is that this is not a coating. This is not a post-treatment. We're not just modifying existing chemistry. We're actually building a brand new membrane layer from zwitterionic materials. And the zwitterionic materials are just naturally water-loving. They're hydrophilic, they are non-stick. And because the way the membrane is engineered, this isn't just a two-dimensional surface property, sort of right at where the membrane surface hits the water. It's actually a three-dimensional property. The entire membrane matrix is made out of zwitterionic copolymer chemistry. So even the internal structures, the pore networks, maintain that water-loving property. So we both see easy ability to clean off the surface. We also see no effect from pore penetration. The compounds or contaminants can't get stuck inside the membrane, and it's a lasting phenomenon. It's not something that wears away. We've had membranes that have been in service for years and gone through hundreds of cleaning cycles without having any wear and tear on the material. We've put our membranes through some pretty aggressive accelerated chemical cleaning programs where there's, again, no impact to the longevity of that performance. So what you get with the zwitterionic membrane is just the most pronounced ability to handle organics without worrying about the downtime and chemical cleaning and challenges from fouling. It's more pronounced and it lasts because it's part of the chemistry itself.
Excellent. All right. On behalf of Alex, Ali, and myself, absolutely want to thank all of you for your time and attention. And hopefully, coming out of this, you'll see where we can help you out in some of those needs where you have around wastewater management and water reuse. So, thank you very much. Appreciate it.